Okay, so I think what I'd like to do is start by talking about the problem set and the last few items in the problem set. And when I say problem set, I'm talking about the ICP, which I think this was the second round on the math of value creation. So I want to talk about those some, and my sense is in doing so, I'm probably going to answer a number of questions that you have. If we then have yet additional questions, which I fully expect that we may, then I'll take some Q&A time from the items that you're working on. You'll remember that because of the holiday and because we didn't have a review session last night, that I extended the due date and time on those items that would have been due tonight at 11:59. I believe I extended those to be due tomorrow night at 11:59. So you could have the benefit of a discussion tonight and then have more than just a couple of hours to throw the rest of your responses together. So we'll do that before we move into any new material for this evening. So with that, let me open up my file on the math of value creation, and then I'm going to go ahead and share the screen. And I believe that you're all able to see my math of value creation solution set. Is that right?
Yep.
Okay. So let's scroll down. I think that this started with, was it I? Was it the WAC equation?
I think so.
Okay, that's what I think as well. So obviously, what we're looking at here then in the middle of my screen is our WAC equation. And in this case, we're looking for a market value solution. And in order to deal with a market value solution, we've already come up with the market values of equity or common equity, E, preferred equity, P, and debt. And to come up with debt, we found the market value per bond using the equation. And a couple of you had some questions during the week that just me, and even though I said this on WhatsApp, I just think it bears reiterating. When we use the market value of bond equation, whether it's the algebra or we're doing the Excel functions, we've got to remember that it's taking C, YTM, and N in similar time constructs. So if C is representing a semi-annual coupon payment, and remember the coupon payment is the face value of a bond, so $1,000, times the rate at which it was issued, and then that number divided by 2, or the periods per year. If we're putting this into semi-annual periods, we've got to put YTM and we've got to put N in semi-annual periods. And that goes for this YTM and N as well. The single most common error in this is putting YTM as an annualized figure. But we always talk about YTM as though it's an annualized figure when we're giving a number. Why is it that we do that when here the first time we're actually using it, it's got to be in a semi-annual construction? Why do we talk about it as an annualized figure?
Because that's the amount of time you measure maturity.
You buy it in annualized terms?
Well, it is the amount of time to mature. It does reflect some maturity issues, but someone else made a comment. I couldn't see who was saying that.
I think, isn't that what you buy it in?
Yeah, so Michael, think about this. If I'm a mortgage broker and I am representing a new mortgage to you, and it happens to be a 3% mortgage, do I tell you that that's a 0.25% rate? Which is what the monthly equivalent of 3% a year is 0.25%, right?
Right.
Yeah, we pay our mortgages monthly. Well, no, I don't. We always talk in annualized terms. So the way that we talk about these things is sometimes inconsistent with the way that we need to apply them. And that's part of the point. And if you can kind of cement that in your heads, and I sense that some of you have, of course, but if you can just get used to cementing that in your heads, it'll help you some. So whatever time signature we've used for C, we must use it for YTM and we must use it for N. throughout.
You just divide those rates by 2 then, right?
Yeah, we're going to divide the rate by 2. We're going to multiply the remaining years by 2.
By 2, right, okay.
Yeah. And Michael and Bella, I see that I see your names, but not your faces. If that's because you're not in a place where you've got a camera structure, that's fine. If we can see your bright, shining faces, I prefer to do that.
Pretty scary.
Well, what was I thinking? Okay. Yep.
I'm still in full no quarantine haircut mode.
Yeah, you got me there, brother.
On second thought.
Jason and I don't have a problem with this. Neither does or David. I'm not sure what the problem the rest of you guys have is. Anyway, so keep that in mind. The second thing to keep in mind is going to be that we have to identify the number of bonds. So here we came up with a price per bond of $847.311 or $847.31. That's the per bond price. And in order to identify the market value of the bonds, we have to identify how many there are. So in this case, we took 628,000, which is on the balance sheet. It's all the way at the end here, 628,000 on the balance sheet. And then we divided that by 1,000 because each bond is $1,000. And the scale here for NMM is actual dollars. It's not in thousands, it's not in millions. So this is a pretty small company, right? It's got less than $10 million in revenues. So we're going to take that then. We're going to multiply it by that number of 847, multiply it by 628 to get the dollar value of the entire bond portfolio, but that's only the bonds. We then have to remember there's some other non-bond debt on the balance sheet. So when we think about this other non-bond debt, we've got interest-only loan, a mortgage, and we've got a credit line. And in this example, I've taken the interest-only loan and used its book value as though it is its market value. Why am I doing that? Why do I not, since this is interest only, why do I not try to create a market value out of this mortgage balance? Lisa, any ideas?
Maybe that's what you're going to, if you were to sell it right this minute, what it would be for, but then maybe a market, I don't know.
No, you're right. You're exactly right. See, there's a very specialized contract that sits between the property owner, the borrower, and the bank. And that is this mortgage instrument, this debt instrument. And it's not one of these that we can just go ahead and say, well, the mortgage balance outstanding is not its market value. Well, the mortgage balance outstanding is its market value because if I wanted to pay off the mortgage, the bank's not going to accept more or less than the outstanding balance. So it's got to do with the peculiarity of the contract, which is not inherent in the debenture. That's what we call a bond contract, a debenture. Okay. Well, credit line, we're going to take the credit line's outstanding balance, in this case 85,649, as though it's the market value. And we don't have that funky debenture thing or that mortgage instrument. We have just a credit line here. So David Bradshaw, I'll let you come off of mute here for a second. Do you recall why we take the credit line's book value as though it is its market value?
Yeah, I don't remember what you said last week, but under my impression, the credit line is a very short-term debt. And so I would imagine that's a reason for why it kind of, the book value is reflected as the market value.
David, it's certainly one of them. So the shorter term the instrument, you can test this out by using the bond value equation, the shorter term, the lower the number of N, the closer the market value will be to the book value always. Okay, because there's not much time for this conflict to arise or work itself out. So Mario, do you by any chance remember the root cause, and you come off of mute, the root cause for the market value and the book value of these instruments sometimes be the difference, or being different rather?
So for like the credit line, is that what you're talking about?
Or for any debt instrument, Mario, why is it that sometimes a debt instrument will have a different market value than it does a book value?
It just depends on the fluctuations of the market itself. And sometimes that doesn't reflect, like kind of what you said with the short period of time. For example, the bond is a long period of time, so we do have to create it back to the market value, but the credit line could be taken out at any moment. So that interest rate is more closely related to what the market value of that would be. And then I guess the mortgages, like you talked about before, I mean, that one's just variable, right? There's a lot that has to go into trying to calculate its market value. And so for our purposes, told us that we would just use what was the book value for it.
Yeah, and I would say that the mortgage, whether it's a variable rate or not, and we see very few variable rate mortgages in the market today. 10 years ago, the market was filled with them, and then we had a crisis and recognized that the market being filled with them was part of the source of the crisis. So today, the vast majority of mortgages are fixed rate mortgages. And so we don't really see that today, but you're right, it's where variability comes into play. When the rate at which a debt instrument is issued differs from the rate that you could get that same kind of debt instrument today, meaning that interest rates have changed for that kind of instrument. When those rates are different, we set up some friction, and the friction is observed in the difference in the value. So if interest rates never changed, if a mortgage is issued, or rather a bond is issued at 5%, and if 10 years later the prevailing rate in the market for that kind of a bond is still 5%, the value per bond will still be $1,000. But if the prevailing rate changes at all, and when I say prevailing rate, I'm purposely using a different term than YTM or than current yield, but they mean the same thing, okay? In fact, oftentimes I will throw at you different terms purposely knowing that they mean the same thing, because you don't live in a business environment that comes out of a textbook. You live in a business environment that's replete with people and all of our flaws and inconsistencies, okay? So if the prevailing rate has changed, the market value of the instrument is going to change. And since a bond is a marketable security that trades on an open exchange, then it's got a fluctuating price or value, unlike a mortgage and unlike a credit line. Part of the reason the credit line doesn't change, and one of you mentioned this, or maybe a couple of you did, is that we don't always know how much the client's going to have outstanding on a credit line. This client's got $85,649 outstanding on the credit line at the end of 2019, but this could be a $1 million credit line. They've only got $86,000 out on it right now. 2 months from now, they might have $20,000 out on it. Another 6 months later, they might have $350,000 out on it. So the bank doesn't know how much they have extended, and because of that, they extend at prevailing rates. So the rate on a credit line is variable. It's moving up and down with the markets. So not only is the prevailing rate always variable, but the interest rate on which we pay interest for a credit line is also variable, and it's moving in sync together. So there's never conflict between the rate at which we pay the interest and the prevailing rate or current yield or YTM. It's important that you remember that the conflict between those is what sets up the difference in the values. And when there is no conflict between them, when they have converged on the same number or are directly aligned, there is no difference in market value versus book value.
So Rick, just to try and kind of compartmentalize or just really shrink down what you said. So is it basically the root of the difference when it comes to debt between market and book comes down to interest rates? Would that be fair to say?
Completely.
Versus there's all kinds of other things we say market value of, right? So let's say we're talking about a stock, or I don't know, the value of a company or the value of an asset, right? Like that's determined by many different variables in the market. Could be maybe more broadly, maybe interest rate has something to do with it. But when we're talking about debt specifically, that's the point you're making, is that those, debt instruments and those values, when we're talking book versus market, is determined by the interest rate. And when they're equal, then they're almost the same. But if there's a big difference, then that's going to create that gap between book and market value.
And more specifically, Matt, when the rate at which the instrument is issued is equal to the rate at which it could be acquired today, when that's equal, they're exactly the same. Not nearly, not almost, but dime for dime, or at least they should be. Okay.
So it's like the bond question I had last week when I was trying to get straight the difference between a premium and a discount, regardless of what that difference is. The point being is, there's no difference if you have a bond that you bought at the exact same face value and 5%, and 10 years down the road, somebody else wants to sell you a bond and it's at the same rate. That, besides the difference in when it matures, right?
Yeah.
There's no difference there. There's just
no difference.
There's no difference in the actual value.
No difference in rate, and because of that, there's no difference in value. So when they're the same, they are exactly equal. And if there is an iota of difference in rate, there is some difference in value. Minuscule or significant, there is a difference in value. And moreover, the longer a period of time between now and the time the instrument matures, the bigger that difference will be when there's a difference in rate. Because time amplifies all rate considerations. Think compound interest.
Right.
Okay?
Okay.
Well, let's come back up to the question here. So now you already know how we got these values. I know this is a review for some of you, but some kind of were stuck on some of this, so I said we would repeat these, and I'll pretty much always repeat these more complex concepts multiple times as we're working on them over the weeks. So we're going to take all of those market values of the common equity E, preferred equity P, and debt D, and we're going to add those all up, and that becomes the sum of the market value of our capital components. And with that, we can then start to think about some weights. So if we take a look in this case and divide the market value of the common equity divided by the market value of all the instruments, we get 76.74% of the components are represented by common equity. We get 6.3% of the components are represented by preferred equity, and 16.97% of the components are represented by debt. And when I say of the components, I'm talking about of the market value of the components, not the number of instruments. Okay? So we've created then the weights in the weighted average cost of capital equation. So we've got the EV, PV, DV. Okay? So now we have to think about the cost. And the cost here, we'll use the CAPM construction or the capital asset pricing model. We'll use that construction to find RE, or the cost of equity. Before I move on with that, why do I refer to this RE, and R typically stands for return? Why do I refer to this RE as cost of equity? How can I do that? Or am I not just kind of creating a problem here? Carol, do you have any recollection as to why I can use return and cost simultaneously? Kylie?
Is it because the return is what you could sell it for? I have no idea.
Not exactly. So Taylor, you're my favorite banker, okay? And you guys don't know, but Taylor is my personal loan shark, and Taylor loans to me at 15% interest rate. I'm a borrower. So when you do that, Taylor, absent any transaction costs, what is the return you expect as the banker to get on this loan or this transaction between us?
15%.
15%. What is it costing me in interest as the borrower?
The same, 15%.
Okay, 15%. Two sides of the same coin, guys. That's what we're looking at here. So return and cost are simply two sides of an identical coin, or the same coin, but we perceive them from our perspective. So as an investor, my perspective was cost. From Taylor's as a borrower, my perspective is cost. As a banker, Taylor's perspective was return. They're the same thing. Okay, try to always keep that in mind. It'll help you. Now, obviously, I said absent any transaction costs. We're assuming the banker doesn't get paid. They don't have any costs of default. They're not paying rent on buildings, etc. But so always we're super simplifying these. Well, that's the RE, and it stands for, or its equation is whatever the risk-free return is. So RF, and you can suppose that to be a 2-year or maybe a 10-year U.S. Treasury instrument. And do you remember why it is that we think that Treasury instruments are risk-free? Diane, do you recall why Treasury instruments are thought of as risk-free?
Maybe because they're not so volatile?
Not necessarily. I mean, they can be volatile when interest rates have changed and when governments stand the risk of default. Andrew, any recollection as to why we think of them as risk-free?
No, I don't remember.
Okay.
Maybe because the government will bail you out and they're subsidized.
Yeah, can't they just, they can just print new money to pay.
Yeah, so Bella's saying this same thing. We're kind of talking over each other. I get that, and that's fine. But Bella's saying the exact same thing. Any entity that prints its own money never has to worry about running out of money. Never has. So you're always going to get paid back. Now, the dollars you get paid back with may not have the same kind of per unit value anymore because of inflation and such, but that's not the point. You're never going to risk not getting paid back when you loan money to an entity that prints its own money.
So just to clarify something on what exactly that is risk-free rate. So for lack of a better term, that's basically whatever the interest rate is on a treasury bond.
Yeah.
Is that correct? Okay.
I will say a 2-year.
Just in layman's terms.
Yeah, a 2-year or a 10-year rate for a 2-year treasury or a 10-year treasury, because you know the treasuries are issued in a very short number of days and all the way up to 30 years. So
why would it just be between those two like lengths of time? Is it something to do with, I mean, I assume there's a reason you wouldn't use like a 30-year.
There is. Does anybody know why that would be, Mandy? I know we've talked about this once a long time ago. Do you have any recollection as to why that would be?
Well, last class I suggested 30 years and you said it's not as safe because the farther out you go, the more uncertainty there is.
Yeah, and you might say, but Rick, you just said that any entity that prints its own money is risk-free, right? Because I said that. And that's true. But when there's more time between now and then, the evils of inflation can start to come and eat away at us. We barely feel inflation any longer on a year-to-year basis. But if we go very far out into the future, it's much more observable. That's why.
Rick?
That makes sense.
Yeah, please, Andrew.
So for what you say, this principle will not apply to European countries since they're not printing their money anymore, right?
Well, yeah, you're right. So what some of you may not know about the EU is that the monetary policy is governed at the centralized unit in Brussels, right, Andrew?
Yes, correct.
And it's governed by the European Monetary Union. However, Spain is able to issue its own debt, denominated in euros to be sure, but its own debt. Greece issues its own debt. Germany issues its own debt. And because the monetary policy, which fixes interest rates and such, is controlled by a different entity than the fiscal policy where loans are created, then you don't have this. In fact, if we're in Europe, Andrew, and we're talking about RF, we still talk about the 2 to 10-year U.S. Treasury rate, even though we might happen to be in France talking about it. Because even the EU recognizes, or even the EU nation states recognize the U.S. Treasury instrument as being the only, quote, truly safe instrument available. Now, there's big quotes around that, right? I mean, I don't want to get into all the political stuff, but there's quotes around.
Okay.
Good point. Thank you for mentioning that. Okay, so the risk-free rate plus then this rate that we can see here in parentheses, RM minus RF. RM stands for the average return on common equity within that particular industry. So if we're looking at a shoe manufacturer, where RM is the average return on common stock for shoe manufacturers in the market. If we're looking at an accounting firm, it's the average return for accounting firms in the market. It's not the average return in the market as a whole. You will find many sources online that will help you look at the CAPM equation and that will delineate what RM, RF, and such stands for. And some of them generalize RM as the average return on common stocks in the market. It's not accurate. Oh, it'll get you a number to be sure. It's just not as finely tuned a number as you want to get, okay? The difference between RM and RF, or the market average return you're dealing with, for whatever market segment you're looking at, and the risk-free return, the difference between those we think of as an equity risk premium, or the additional return that an investor should be realistically able to get by having invested in a marketplace of equities rather than in government bonds. Okay, so it's the additional return. But remember, when we say return, what is a synonymous word for return that is not cost? So we have two substitutions here. We just said that cost and return are synonymous or substitutable. Is there another word that we can substitute with return? Or is there another word we can substitute for reward?
Profit.
Say again, Diana?
Profit.
Not what I'm thinking about, although I understand what you're saying. That, yes, in another context we could, but it's not what I'm thinking about.
Risk?
Interest?
Risk. Risk and reward are two sides of a coin, right? Just like cost and return are two sides of a coin. And we very often will think of reward and return, which Diana is right, is a function of profit. But reward and return we think about as being synonymous.
So would you say that if the difference between RM and RF, the larger that number is, would that be associated with a higher risk?
Well, I would think you'd have to, yes. So let's look at technology. I mean, in the tech industry, there's going to be a big spread between RF and RM, right? In healthcare-related products, health tech and biotech and such, big spread. But we also know big risks. Big risks. Okay.
Right. The further you give that RF, the higher the risk you got, basically.
Yep.
Because
exactly.
it's your most conservative investment.
Exactly. And when we interact this equity risk premium with beta, and remember that beta is an individual company's volatility measure. It's a statistical measure of the price volatility of that company, that individual company's stock price. When we interact this equity risk premium with beta, we end up with the company risk premium. So we've taken the industry risk premium times this volatility measure, which is beta. And when the volatility, the price volatility of an individual company's stock is equal to the volatility in the industry in which it exists, beta is 1. And when the volatility is greater, beta is greater than 1. When the volatility is less, beta is less than 1. It's pretty unusual to see a beta of less than about 0.7 or greater than about 2. It's not that they're not out there, it's just they're not commonplace.
So when you're looking at a beta on, just say, like, you look up a stock on like Yahoo Finance and it lists all the stuff, and one of them is the beta. Yep. You're saying that those betas are always calculated based off of what you said earlier, the industry, not the market as a whole. So it's the company's performance volatility compared to the industry's volatility. Is that right?
That is what it should be. And I believe if you go to Yahoo Finance, I believe that's what you see. I'm not sure about Google, but I do know that if you look at Bloomberg, or if you look at FactSet or Value Line or Market Watch, you're going to see a beta that lets us know about the volatility compared to the industry in which this company exists, not the entirety of the market.
But I guess probably now that I think through it, the better point there is that regardless of who shows what, let's say they show both, you might it probably gives you a more accurate picture if you look at the one that's based on the industry, because you're looking at more of an apples to apples versus some, other non-relative term.
The farther down the funnel of specificity you get, the more accurate your outcomes are. That's exactly right, Matt. I mean, and I know I'm using different words than you just used, but they mean the same thing in this case. Okay? So that's the version we're using to get to RE here. Now, I showed you a version of RE in the corporate finance quick sheet that I'm going to come back to when we look at the Gordon growth model. And it's a version you will only use when you don't have the attributes or components of CAPM. I wish we had the components of CAPM to calculate RP, or the return or cost on preferred. But because preferred stock offerings, public and private, have such a wide variance of attributes, and because it's oftentimes one company will have numerous preferred offerings at any moment in time. Bank of America, the last time I looked at it, had 52 different versions of preferred stock in the market at one point in time. Because of those, we never see published beta factors for preferred. You can create it because it's simply a statistical variance structure, but I'm never going to expect you to calculate it. So I'm going to tell you that we'll find RP by taking a look at the preferred dividends paid for a particular year divided by the market value of the preferred stock for that year. So Michael Schwartz, I've had a lot of young students in this class, few of them with pacifiers, and good for you, Dad. Okay, how old is Bing?
She is 6 weeks today, actually.
Oh, good for you, man.
But I'm just trying to keep her not crying right now. So.
I understand altogether. And if we sing along, well, you want somebody to do it other than me. We won't go over lines. Okay. And then RD is going to be synonymous with the current yield or the annualized YTM for that same kind of debt in the market today. So if my company, Haskell Enterprise, went out to get debt in the market today, I wanted to borrow some money, my RD would be whatever the bank or market would charge me for that money today. So we have to look at the company's industry. We have to look at the Standard & Poor's or the the credit rating, if you will, of the company. We have to look at how much it's borrowing compared to its assets or its equity or its revenues. All of these things that you might think about as homeowners, perhaps, or whenever you're doing any borrowing for cars or what have you. The same constraints or considerations go into play here. And then so does the tax rate. We have 3 tax rates that we have to consider. Jason, do you recall what the 3 different forms of tax rates are that we might have to think about?
No, not off the top of my head, unfortunately.
Kate, do you?
Tax on taxable income.
Okay.
And also, I don't remember off the top of my head the other 2.
Anybody can jump in.
Tax on EBIT.
Okay. And by the way, those 2 we will routinely use. We will never use the third. What is it? Is the tax rate that we can calculate by taking the amount of tax the company paid and dividing it by its taxable income. Michael Allen, do you remember why we'll never use that?
Isn't it because the amount of taxes that a corporation actually pays can wildly differ on what they're supposed to and like how they kind of manage their money and what?
Is that the discretionary one?
Say again, Lisa?
The discretionary one?
Yeah, it can wildly different because of how they've managed, because of whether or not there are discretionary elements in here, tax credits, write-offs, loss carry forwards, etc. You're both right. Well, good for you. Okay, so now we've gotten WACC. We take the weights times the costs. The last one for debt, we're interacting with the tax rate because it's after tax, and that gave us, in this case, a WACC of 12.77%. Long way to get to a little number, right?
Rick?
Yeah.
Do you want us to show you the whole process also in our answers, or would it be enough for us to just give you the less formula with the numbers?
That's a really good question, Andrew.
Since we are adding also the spreadsheets.
Yeah, so here's how I prefer to see your problem sets. You know that I give you a Word document in the problem on Canvas, the assignment on Canvas, which is the information and the questions. And you also now know that I give you a PDF, which is the same questions and information, but with the solutions, okay? If you want, or rather the way that I prefer to see your homework submissions is for you to go ahead and just do your work in a spreadsheet, copy the answers from the spreadsheet into the Word document, save the Word document to a new file, submit that document and the spreadsheet you use to calculate the answers. That's how I prefer to see these. If we had a live class construction, then I might, for some of these, want to see your handwritten calculations, but we're not doing that this blog because we don't have a live class construction. Okay, good question. Okay, so I know that took us a long time to get to a really important place, and that was WACC. WACC is nothing but a discount rate. We know that all time value of money equations include a discount rate in the denominator. We're going to review some of those equations this evening together, but all of them use a discount rate. WACC is the company's discount rate from the perspective of the company. Now, if Shenzhen was an investor and come in and say, well, yeah, fine, Rick, Haskell Enterprises has a 12.77% WACC or National Media Management, but I don't care. As an investor, Shenzhen never is willing to settle on less than 16% expected return. Well, in that case, that would be a hurdle rate or a required return, and that's also a discount rate. But in this case, it's a discount rate from the perspective of the investor as opposed to being a discount rate from the perspective of the firm. So a hurdle rate, a required return, a weighted average cost of capital, interest on borrowing, inflation rate, those might all be credible forms of a discount rate, but they may be different numbers. So just keep that in mind. Any question as to how we got here to this point? So hopefully some of the things you went through the week helped reinforce some of this. In fact, I know it did. Any questions about the investment rate in item J? My guess is that was fairly straightforward. What about item K? When we're looking at this value at time t equals FCF at time 1 divided by WACC minus G. Any questions about that?
This is where I kind of started to run into some issues, Rick. So like with this question, I think doing the actual calculation was fairly simple.
Yeah.
But I guess I just did, and kind of this goes along with the last of these, from here on out. I guess I just don't understand what it is we're even calculating.
Okay,
like the value T, what is value T? And it says, this is a augmented form of the Gordon growth equation.
Yep.
And so anyway, I didn't necessarily have trouble doing it because I know how to get those variables, but
what do they mean? Well, it's kind of a so what, isn't it?